Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Dianna Dini.
Hey, Dianna, we've been doing that opening kind of as an opening routine, and sometimes you would take the lead and or the other host would, or, we vary it slightly, but it's basically a starting banter so we could signal that we're getting into the podcast. Mm-hmm. And then we shortly thereafter, do what we're talking about, and then we discuss it back and forth. And then I have this closing thing I do to encourage people to get in touch with us. Well, it turns out that works. I got a question the other day, and it was more about reliability planning. Is somebody had heard us in one of the podcasts, and we have said the plan should not just be the copy of the last one you did. It should be unique for that program that the challenges and constraints you're facing at the moment. And it was, but there's some things we do every time. And so how do we separate what we should do routinely? What is the routine part of reliability engineering? And what is the unique, or, which parts do we need to really think about and focus on and craft a unique part of our plan to do this? And so it was trying to separate, if we're not going to just copy an old plan, but there's some things we do routinely. How do we separate that? And I don't know if you ever run into that issue or saw the benefits of not using the previous plan.
Yeah, well, I have the quality background, and quality people like to standardize things. Yes, and standard processes for things, but there's a place for having a standard process, and then there's definitely places where it doesn't fit, that you have to work within the confines of a big process. But you have particular things that you need to work out, like vacation. Like every time I go on vacation, I have a certain process for getting packed up. Mm-hmm. But depending on where I'm going to be packing different clothes, different shoes, or in different amounts. But there's a general process that I take. I have a little checklist.
You really are quality.
I have a checklist of the things like I can't forget. My medicines, my sunglasses. Whatever.
Yeah. No, I did the same when I traveled a lot for business. It was just a routine. I'd kind of go through a checklist and go, all right. After you forget to pack socks twice, then you realize I better make this more systematic. But in reliability, we do have pretty good processes for some things, and they overlap a lot with the quality world, like root cause analysis, right? Mm-hmm. Like the 8D process many people use. We build a team, we identify the problem, minimize immediate damage, and we kind of go through. Most organizations have a pretty standardized approach to doing it, but every root cause analysis is different.
Yeah.
Because it's different circumstance, different impact, different mechanisms. You might use a microscope one time, and you might use the scanning electron microscope the next time. The process provides a structure to go through it and to pick the right tools and go on to it, which then, for whatever reason, doesn't translate well to when you're creating a reliability plan. I find so many organizations that say, well, our last program we did is a similar project to what we're doing now, and it worked last time, so let's just do what we did last time. It's sort of like putting your foot in a river, right? It's different every time you touch it.
That is curious too, because even project management projects, like if somebody was doing project management and doing the plan for the project, like, oh, we developed a catheter last year, let's just copy over the same same plan for our project management plan, and that doesn't translate either.
No.
Because you're starting from a different place. You're going to have maybe some slightly different features. Maybe it's a different customer base. So yeah, it doesn't translate for project management stuff either. Or like you said, reliability plans.
Project managers, they have new challenges this time. So the plan has to be different. Yet I have seen people take reliability plans and step and repeat them for decades and wonder why they're not getting good results anymore. And let's have a standard process for how to create a plan, right? But that process is, well, what are you trying to achieve? What's important? What do we know and don't know? What do we need to know? So, for example, will this new vendor's component last the 10 years we need it to last? Well, that suggests doing an accelerated life test on that particular product's dominant failure mechanisms. If you don't have that question in that program, then don't just run an accelerated test, because it doesn't answer a question that you need answered.
Do you think maybe that's the disconnect there, that there's, we need to take time and assess what do we know now that we didn't know when we did stuff the last time?
Right.
Or what's new, what's different? What are the unknowns that we need to take a minute instead of just taking the old plan? We need to take a minute and understand what the deltas are between what we did for this project over here versus what we know and what we don't know for this new project.
Right.
Do you think that's part of the...
Well, that's part of it, is you got to step back and what do we need to know? And then you figure out, well, what tools and techniques do we want to use? What methods are we going to pull off the shelf to go answer those questions, to provide information? We often forget that we don't do reliability testing just to do reliability testing, although many people seem to believe that. They have a whole room full of chambers and equipment, and by golly, they're going to use it. Well, should only really use it if it's going to create meaningful, useful information for somebody that they can actually act on. And that's, I find that there's some empire building in some organizations that they go, oh, we got all these chambers. We need to throw everything in these chambers and run it. Why? And they don't step back and answer that question. And so part of it is this walking around the room basically and saying, what do you need to know? What do we know and don't know? And somebody says, oh, we're looking at these two vendors for this part of the product, and we don't really know which one will be better. Well, define better. Well, it'll function for the 10 years we need it to function. Oh, okay. Well, that's a reliability problem. We can help with that. Let's understand that technology and figure out how to evaluate this. And it might be from vendor data. It might be from their own test data. It might be from, maybe we have experience with it, or maybe we need to run a test. But it's start with what's the decision that needs to be made, and then what information is necessary to help inform that decision so you make the right decision. That part should be standard. Figure out what you need, what information you need to create, and then pick the tools to go create it, not the other way around.
Just putting on my quality hat for a minute, this would happen with inspections too. So whether you have in-process inspections or end of line, or even incoming inspections of components that are purchased, there was a need to, or the basic thing that people would do is they would copy over whatever was from another part that was similar to it or in the same category.
Right.
But sometimes those inspections or those measurements, like you mentioned, they weren't doing anybody any good, or what the information or what they were looking at really wasn't providing the right feedback to say whether or not the parts were good or not good. So there's a tendency to try to standardize a lot of those things where, again, we need to step back and just take a look at, all right, what is it we really need to know about this part? Maybe it might be that it's can undergo the standard inspection, but it's worth stepping back to consider it and take a look at it for what we're doing.
Well, I actually had a circumstance where this team was measuring their products. I think it was every week or every month. They basically ran a whole slew of samples through what they did at the end of the development project. So their final qualification runs of tests, all kinds of functional tests and measurements they were doing. And it was very expensive. And nobody ever looked at the data. And so I finally got a hold of it. And some of the CPKs were like 25, 30. They were so far away from ever having a problem on those things and never did. And there was like one or two of them that were signaling every single field failure event, that they were getting, the major problems. This one process would go out of whack on occasion. It was all in the data, but nobody ever looked at it. And so I presented all that and said, one, you can stop 90% of these tests. They have no value whatsoever except for the team that's running the tests. It gives them something to do today.
Mm-hmm.
But you're wasting millions of dollars doing that. Let's focus on these three and then take steps in this design process we're doing right now to eliminate the need to do those tests. And they're like, oh, you can do that? And yeah, you got to step back and say, what are we using this for? The running tests and collecting data just because you want something to compare only works if you actually do the comparisons and it's meaningful or useful for you. If you do it for the last 10 years and you've never, ever taken action on any of the results you've ever gotten out of that measurement system, you might want to just not do it anymore.
Yeah. And I wondered if that was sort of, they wanted to do an initial monitoring, but then look at the data and decide what to do and then stop some of the stuff if something happened where it just kept going.
Well, part of it was cultural. It was a Asian team that was running the tests, and they weren't going to step up and say, hey, we got some anomalous results and something's going wrong. It just wasn't in their nature to say, oh, we're going to stop the line, because their, production manager was ship it, run the line. We got quotas to meet and numbers to meet. And the people doing the procurement and the sales forecasting, all that stuff was like, well, you got to get gazillion of these out and just do that. But the engineering team moved on to the next project. They said, all right, we're done with that. It's manufacturing now. They'll take care of it. But nobody picked up that role of saying, are we doing the right things now? And there was consumer products, and they were every 6 months, they were rolling out new versions, new products, and all that kind of stuff. So they were very constrained on time, but they really dropped the ball of, all right, well, we set up a monitoring system and let it run. And they had very little time. So they said, well, we'll just do what we did to qualify it. That'll be good. And walked away from it. And it was an amazing pile of data, right? It was really amazing amount of information.
Almost dreamy, right?
Oh, it was. It was great. And they did an excellent job running the tests and monitoring the systems and recording all this data. That was beautiful. But it was millions of dollars of just useless information.
Yeah.
And that irks me. So the idea of running a standard plan for reliability is, we're going to do HALT, and then we're going to do an FMEA, and then we're going to do this, and we're going to do that, and we're going to run these 15 different tests, is misguided. The process starts with, well, what information you need, and then back up, well, what tools and techniques are efficient for us to provide that information. But if you're doing something that nobody cares about or needs or wants to look at, don't do it. Yeah.
Now, I have seen, reliability programs that instead of saying we're going to run these tests, it's at certain points of a development process, we're going to talk to you about these kind of questions. Or if you're looking at these kind of things, we want to talk to you at this point about this kind of stuff. And there would be, a 9-step process for a reliability program that was kind of interweaved with the product development cycle. It's just how they worked it out to get reliability involved early.
Well, would that be like in the very first phase, the concept phase is, well, what's the objective? How long is this product supposed to last? Let's have a goal,
Yes.
that kind of stuff. It's kind of the product life cycle.
And that's how it would start.
Yeah.
It would start there. And then like we've been talking, it depends on the project. You may not need step 3.
Right.
But you could decide, we have this checklist, we have step 3, but based on everything we've talked about, we can make this step smaller or we can skip it if we need to. But you're doing it purposely, you're not just winging it.
Well, I like the framework like that is asking the right questions, and makes parts of the reliability elements visible and conscious.
Right.
Right. The hard part, though, is that a lot of times it goes, all right, well, at this stage, I have to ask for how many samples I need. Well, in order to know how many samples you need to run testing, you need to know why you're doing the testing.
Right.
Are we at the right stage to do that? And so the question shouldn't be get your sample size order in. It should be, what information do you need that you can pull from samples, extract from samples? It's usually not phrased that way. It's like, oh, get your order in for the prototype runs.
Oh, I see what you're saying. Mm-hmm.
Yeah. So it has to be, I think, phrased correctly so that it gets you to focus on answering the question, why are we doing this? Not, all right, we're going to run tests, so we need samples.
Yeah. Instead of like the good old quality check sheet, you need this. It's more of an open-ended question at this point in what you're doing.
That's right.
Right?
Yeah. I mean, one time I was working with a program manager, and it was a medical device, and it's like, at some point you're going to have to find out, is your product meeting your reliability requirements? And that the reason I was there is because they were really focusing on trying to make a product that actually worked in the field. They've been having problems with that prior. And I said, at some point you're going to want to be able to, because setting a goal is pretty meaningless unless you measure it and track it. And are you on track for doing this or not? So part of this is we need to figure out what are the areas that are most likely to fail. And, oh, that's a good idea. And how do you do that? Well, FMEA is a good way to do it. Let's do that. And then from there it was, oh, okay, in order to answer this question, we need to do this thing and this thing. But it was a structure of what do you need to know next? And some of it was routine. If you set a goal, you should probably track it in some form or fashion. But it could be modeling, it could be simulations, it could be using historical data and only focusing on estimating the new parts or new elements of it, and so on. There's lots of solutions for it. It doesn't mean you have to do a system-wide accelerated test.
Right.
And that's where I think it breaks down, is that so many plans I've seen is that, well, we've got a temperature humidity chamber, so we're always going to do temperature humidity testing. Okay. Have you ever learned anything useful out of doing a temperature humidity test? Well, sometimes it fails and then we ignore it because it's at such high temperatures. Okay. Let's try a different technique.
Yeah. And I guess that kind of brought us full circle back to what you mentioned at the beginning, which was root cause analysis.
Yeah.
That there's certain frameworks of steps that you follow through to find the root cause of something, but whatever particular tool you decide to use or analysis depends on the problem that you're looking at.
Exactly.
And it's the same way with reliability.
Exactly. When setting up a reliability plan, it's by happenstance, and maybe the part of this question is because Carl and I are getting closer. Hopefully when this comes out, it'll be published, is a book that goes through 6 steps to create a reliability plan. And I just outlined a good part of it. So it's the process of reliability engineering. I think we finally settled on a title for it. But it goes through in great detail that element that Carl and I, when we were working on this book, and what is the process to create a reliability plan, essentially, was that the heart of it is you got to figure out what you need to know. What are the decisions that are pivotal to make a good product. And if those are well-informed decisions, you're more likely to actually achieve your goals. And so if it's, pick vendor A or vendor B, which is the heart and soul of the performance of your product, and reliability is not part of that equation, or you have no way of measuring it, or you don't even ask about it, then it's 50-50, which one is the right one. But if you, evaluate some data or, assess the two different vendors or run tests on it, you can tip that balance away from just a flat guess to an empirical informed decision and change the balance of getting it right.
Yeah. So I think this was from a listener's question.
Mm-hmm.
And sometimes about copying over a previous reliability plan to apply to a new project and just doing it. There is something to be said too about it's almost like benchmarking. But if you develop your plan based on your questions, it doesn't hurt to look at the previous plan and see what did we do different, and are we still okay? Are we missing an idea? Did we previously plan to test something and it didn't work out so well? Why not? How could we do it differently this time? So you're still learning and continuing to build on what you learned from the last time, but it's not a blind copy paste. You just have to put thought into it.
Yeah, and I think Chris Jackson likes to talk about it. You really can't, as a reliability professional, you really can't check the brain at the door when you get to work. It does take thinking, as hard as that is to hear sometimes from some people. And that's where we can make a big difference. Is have that structure of steps to, what are we trying to achieve? What information do we know and don't know? How can we create the information to inform those decisions, those priorities? And then how do we monitor it, right? How do we know when we're on track or not on track? Those kinds of steps are a great way to create the set of tools and techniques and methods that we're going to put into a plan. And then it's a whole different challenge to actually execute it. And everybody knows about trying to get enough samples, but you have a much stronger argument tied to what is of most use to your team if you go through those first steps, that first framework part of it, as opposed to saying, all right, now I need 4,000 samples because we're going to run plan B. We might have like a football team. We're going to run an end round on this one because it's pretty easy. We're going to skip all of the stuff in the middle. We'll just go around it on the outside. You might have different, scopes of projects. There's no doubt about that. Yet the same framework is, well, what do you need to know? What's the information you have? What's our constraints? And then dealing with that versus saying we're going to shove all of this stuff into a plan every time. And that generally is not a way to get to achieving the reliability objectives you have.
Right.
Yeah. So anyway, I got a plug-in for the book. Hopefully we actually get it published. As we're recording this, Dianna, we're getting proofs from the printer to see how it looks in print. And Carl got his yesterday. And so he's already said, I've got comments, and I haven't got my copy yet. So I'm kind of curious how it's going to turn out.
Yeah, but congratulations. That's a good step.
It is a good step. Yeah, we're getting close. But we'll see how well it prints. And that'll define how long before we get it published is how much more editing we got to do. But we'll see. Maybe it looks great and he's just happy with it. And I'll find out later today, I hope, when I get it. But anyway, I got to plug the book. Hopefully it's out by now when the recording airs. But we'll see. Don't do this every day, so I don't know how long it's going to take.
Well, I'm sure it'll be very valuable to the reliability community.
Oh, thank you.
I'm looking forward to it.
All right, cool. So anyway, if you listening to this, and so hopefully it answered the person's question, and hopefully maybe helped a few others of you think through, your reliability planning, the technique, the framework you're using to get to it. let us know. Is this useful information for you? Or more importantly, if you've got a question or a comment you'd like us to discuss, let us know. Head over to accendoreliability.com/go/SOR, and you can find a couple of ways to get in touch with us there. Dianna and I and the other hosts of the show are available through LinkedIn and our About pages on Accendo. So plenty of ways for you to get in touch. And a routine part of our process is to ask you to get in touch. And thanks to all of those that have done so. So we certainly appreciate that. All right. Well, thank you very much, Dianna. We'll talk to you again soon.
Thanks, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.